Hi guys, so today we're going to learn our last operation on radical expressions. This is going to be about how to divide radical expressions. So let's get started. Okay guys, so mathematical conventions, all that means is how I write things in math, tells us that in order for a radical expression to be simplified, we cannot have a fraction underneath a radical. So take a look at this example. Here I have the square root of 1/2. That is a fraction underneath a radical. Mathematics convention tells me I cannot have that. I'm just not allowed to write it like that. All right? So I know by the laws of radicals that I can just change this, right? When I'm dealing with division and radicals, I can just split that and I can take that radical and put it over the numerator and the denominator. So the square root of 1/2 is the same thing as the square root of 1 over the square root of 2. We know what the square root of 1 is. It's 1. But the square root of 2 doesn't simplify very easily. It's not nice and pretty, so it stays the square root of 2. There's nothing we can really do to simplify that anymore. The other thing mathematical convention says is that we cannot have a radical in the denominator. So here, when we sort of changed this original expression to get that fraction out from underneath the radical, we turn it into something else we can't have. We have this radical in the denominator now. That's also not allowed by mathematical convention. We just, as a bunch of mathematicians, we just say, when we write radicals as fractions, we cannot have a fraction underneath a radical, and we cannot have a radical in the denominator. Those are just two rules that we have to live by. So we have to do something to this expression now to get this radical out of the denominator. And here's what we do. To change this, we multiply by a factor of 1. It doesn't actually change the value, only the look. And this is called rationalizing the denominator. So when you take these expressions and you multiply by a factor of 1 to get rid of that radical from the denominator, it has a name. It's called rationalizing the denominator. And like I said, when you do that, it doesn't actually change the value, only the look, right? Because we don't want to change the value of this expression. We just want to change the look of it. We just want to get this square root out of the denominator. So this is perfect. So let's look at an example. Let's forget about radicals for a second. Let's look at an example just so I can show you that it doesn't actually change the value. It just changes the look. Let's look at the fraction 2/3. Okay, let's say I want to rationalize this. I want to multiply by a factor of 1. So here's my factor of 1, 3/3. We can all agree that that's equal to 1, right? So in essence, I'm just taking 2/3 and multiplying it by 1. All right, but I've been really intentional about what I've picked, what 1 I've picked. So 2 times 3 is 6. 3 times 3 is 9. So we've changed 2/3 to 6/9. Now we haven't changed the value here. That's important, okay? 6/9, that's still equal to 2/3, right? If we reduce 6/9, we get 2/3. So they're still exactly the same in value, but we have changed the look, right? It no longer looks like 2/3, it looks like 6/9. That's what rationalizing the denominator does. It doesn't actually change the value. It just changes the look. So now let's look at our example. We have 1 over the square root of 2. We want to change the look of this, not the value. We just want to get that denominator. We don't want a radical in there anymore. We want to get that radical out of the denominator. So we think to ourselves, okay, well, if I don't want a radical under there anymore, what can I multiply by 2 so that the product is a perfect square? Because I want to multiply this by something that gets rid of the radical. So I need a perfect square in the denominator so I can get rid of the radical. Well, I can multiply 2 by 2. So I'm going to take my radical expression here, 1 over the square root of 2, and I'm going to multiply it by the square root of 2 over the square root of 2. Again, we can all agree that the square root of 2 over the square root of 2 is equal to 1. Anything over itself is equal to 1, right? So I'm, in essence, just multiplying by a factor of 1, but this does something really nice for me, right? Well, 1 times the square root of 2, that's just the square root of 2. And the square root of 2 times the square root of 2, 2 times 2 is 4, so that gives me the square root of 4. I know what the square root of 4 is. It's 2. And this just remains the square root of 2, right? So what I've done here now is I've taken this expression that I couldn't have, because I cannot have a radical in the denominator, and I've now turned it into something where the radical is no longer in the denominator. All I cared about was getting the radical out of the denominator. And that's what I've done. So now this is fully simplified. So instead of writing it as 1 over the square root of 2, it's now the square root of 2 over 2. They are the same value. They have the same exact value. If you punch both of these into your calculator, you'd get the same thing. But I needed to change the look so that I no longer had a square root in the denominator, and I no longer have that. So same value, just different look, right? Okay? And that's what you're going to do every single time. Whatever is in your denominator, you're just going to use that and multiply it by that value, that factor of 1. You're going to take what's in the denominator, put it in the numerator and the denominator to get your factor of 1 and multiply, okay? Because that will give you the perfect square you're looking for in the denominator. That's what we're going to do, all right? So when you're dealing with radicals in the denominator, these are the 3 methods you're going to use, and you're going to use them in this order. The first thing you're going to do is try to reduce, okay? So here I have a fraction underneath a radical. I can't have it. Well, let's try and reduce what's actually underneath the radical first. So 75 over 3, can I reduce that? That's the first question you're always going to ask yourself. Can I reduce it? Oh, well, 75 over 3, that's just 25. That reduces to 25. What's the square root of 25? 5. All right? So the first method you're always going to try is to try to reduce. If reducing does nothing for you, you're going to move to the second method. You're going to split. All right, so here I started with the square root of 49 over 9. I say to myself, ugh, I can't have a fraction underneath a radical. By mathematical convention, it's not allowed. All right, I can't reduce 49 over 9. All right, so let me try and split it. And all that means is I take that radical and I just split it, put it in the numerator and the denominator. So instead of the square root of 49 over 9, let's try the square root of 49 over the square root of 9. I can do that by the laws of radicals. So the square root of 49 is 7, and the square root of 9 is 3. Oh, that worked beautifully for me. I'm done. All right? So first thing you always try is to reduce what's underneath the radical. If that doesn't work, split what's underneath the radical. See if that does anything for you. If that doesn't work, you're going to split, and then you're going to rationalize. You're going to multiply by that factor of 1, just like we saw on the previous slide, right? We split it. We couldn't reduce, so we split, and then we wind up with this radical in the denominator. Oh, I can't have radical in the denominator, so I'm going to multiply by that factor of 1, and that gets the radical out of the denominator. So you always go in that order. Try to reduce. If that doesn't work, split it. If splitting doesn't work, well, keep the split, but then multiply by a factor of 1 to rationalize and get rid of the radical in the denominator. So let's take a look at a few examples. Okay, so if you guys feel ready, you can just jump into some examples. Remember, just go in the order of first try to reduce. If it doesn't reduce, then split. And if the split doesn't help, then multiply that by that factor of 1 to rationalize the denominator. I am also going to make a second video going through 3 examples. So if you don't feel comfortable jumping in quite yet, you can watch the next video and try some along with me and then jump into these examples that I have right here. All right? So good luck and have fun.